Okay, sorry about that. Wrote it. I'm just going to put 9 tangent square theta for shortcut. Okay. So what do we do from here? We substitute that in. We end up with square root of 9 tangent square root of theta plus 9. We can do something with that. We can factor out the 9. It's all under the square root still, so it's 9 parentheses tangent square root of theta plus 1. Do you know what that is by chance? I don't know. So I'm going to use my Pythagorean theorem in trigonometric form. Sine squared plus cosine squared equals 1. I like to use short notation so that way I don't have to write it all out. Tangent, I want this to be divided by cosine squared. So I get tangent squared right there. Divide by cosine squared, divide by cosine squared. That becomes tangent squared plus 1 equals 1 over cosine is the secant squared. Okay? So I'm not sure if you can quite see that. Okay, there we go. So tangent squared plus 1 becomes a secant squared. So what do we do? Square root of 9 times the secant squared, excuse me. There it is. Since it's one single term, you're multiplying 9 times that. Becomes square root of 9 times the square root of the secant square root of theta. Square root of 9 becomes 3. I don't like the way the book does it. It's kind of, at the 9th grade level, trigonometry students, the honor students, it's a little bit difficult to comprehend this. For the juniors too as well, it's a little bit difficult. They actually say this is equal to the secant of theta. The square root cancels, but it becomes the absolute value. I'll give you a little bit of intuition why that happens the way it happens here. Okay? Well, if I give you the square root of 5 squared, that becomes square root of 25, which becomes 5. So that's fair. What about if I take the square root of negative 5 quantity squared? That becomes the square root of 25. The negative disappears somehow, becomes 5 again. So if I take the square root of x squared, it becomes the absolute value of it. Not the negative portion, it has to always be the positive portion. The absolute value means always positive. So you're starting to get used to what the absolute value does. It's going to be really, not really tricky, but just a little bit tricky once you get down. So the square root of the square is the absolute value. If your teacher makes you do that, fine. If it doesn't, fine. You can just also write it another way. You can call that 3 secant of theta. Okay? It depends on the teacher. If you're in calculus, you definitely have to use absolute values when you take the square root right here of the square of this portion. Okay. 17 minutes has elapsed, so we actually have a little bit of time to do some of the problems here. Let's actually do some of the problems. Number 1, 2, 3, 4 is just like example number 1, I believe. Let me just make sure of that. Yeah. 1, 2, 3, 4 is just like example number 1. 5, 6, 7, 8, same thing. Let's actually do some of these simple expressions and try to work it out. 14. Cosecant of theta over the secant of theta equals 1. And they only want you to use sines and cosines. So the answer must be in sines and cosines. We know that the cosecant is 1 over the sine divided by the secant is 1 over the cosine of the angle. You have a really complicated fraction there. It's called a complex fraction. So we multiply by the reciprocal. Cosine of theta over 1. That cancels that out. If you don't know how to do this, it's actually dividing by 1 over cosine. Change the division symbol to multiplication and reciprocate that. That becomes cosine of theta over sine of theta. They want you to write it in terms of sines and cosines, so it's actually find an answer. But if they want you, you can actually simplify this one too as well if you want. The cosine of the sine is equal to cotangent of the angle. Okay? So make sure you can, I think I threw the 1.3 away. Not threw away, but let me see if I have some of this. Yeah, I only have the examples here, but from 1.4, 1.3, you have a lot of information, so you're going to have to reference everything builds up. Okay, guys? Let's do some more. 21. Yeah, let's do 21. Find the tangent of the angle plus the secant of the angle. And you want to simplify the expression. The tangent, we know that that's equal to the sine of the angle over the cosine of the angle, plus the secant is 1 over cosine of the angle. Since we have like common denominator, we can just add the numerator. Sine of theta plus 1, you cannot add those. It doesn't become 1 sine of theta. You have to add those. And the common denominator is cosine of theta. Should be pretty simple. 27. Do I want to do 27? Yeah, let's do this one right here. 33 is a nice little problem. Or do 34. Let's do 34. 34 says 1 over cosine of theta minus cosine of theta. What? Equals what? Oh, let me put this right over here just a little bit. 1 over the cosine theta minus cosine theta equals 1. What? Question mark. Well, your natural inclination right now is to change this to the secant of the angle, but you don't know what the secant of the angle minus cosine of the angle is. So we're going to have to do common denominators. So that becomes 1 over cosine of theta minus cosine of theta over 1. We have the common denominator, so I'm going to multiply by the cosine, the top and bottom. I'm going to use short notation. That becomes 1 over cosine minus cosine squared over cosine. I'm going to use short notation here. Let's write it here. That becomes 1 minus cosine squared over cosine. That's interesting. We've seen this before, something like that. Whack your brains, guys. You know, the Pythagorean theorem in trigonometric form is sine squared plus cosine squared equals 1. If I move the cosine squared to the right side, I know that sine squared is equal to 1 minus cosine squared. I'm going to substitute that in there. You have to make the substitution because that's not a very simple fraction. Sine squared over cosine, excuse me, sine squared of theta over cosine of theta is a better answer than 1 minus cosine squared over cosine squared. So, sine squared of theta over cosine theta is the better answer to use. Okay. Let's do some multiplication just to make sure that you guys got it down a little bit. Running out of paper here. I'm going to have to use another set of paper. Sorry about that, guys. It's kind of messy. Okay. Let's do 44. Cosine of theta plus sine of theta squared. So what we're going to do is we're going to try to simplify this expression. Okay? The square, you cannot distribute this out straight out. You have to fold it out. That becomes cosine plus sine times cosine plus sine. I'm going to use short notation. Cosine times cosine, cosine squared of theta, plus cosine times sine, cosine theta times the sine of theta. Sine times cosine, same thing. Sine times cosine is cosine times sine of that angle. Sine times sine is sine squared plus sine squared of theta. Notice something, guys? It was kind of looked like one of your problems, didn't it? You saw the Pythagorean theorem 5 times, I believe, just about, I don't know, 4, 6, somewhere around there. Pythagorean theorem 4, 6, maybe 7 times so far. Cosine squared plus sine squared is equal to 1 plus cosine theta sine theta plus another cosine sine theta, which is 2 cosine theta sine theta. There's your final answer. Okay? Let's do some of the harder proofs. 53 seems to be a pretty good one. Show means prove, right, guys? These aren't that hard. It gets harder in chapter 2. So cosecant theta over cotangent theta. Show that that's equal to the secant theta. We're going to try to prove that this is the harder part, and you're going to try to make it into secant theta. We're going to use what's called a little bit of a cheat method, and then uncheat ourselves. And teachers don't like this very much. I'm not sure if teachers do like it or not, but I'm going to use a cheat method, okay? And see if it works out. We know that the secant theta is equal to 1 over cosine theta. So if you can make the left side of the equation look like 1 over cosine of theta, then you can go back into and uncheat ourselves to become the secant theta. So you're going to use this technique quite a bit to try to massage the expression to make it look like the expression on the other side. So we know that 1 over cosecant theta is 1 over sine of theta divided by cotangent theta is the cosine of theta over the sine of theta. That's equal to that. We're going to multiply by the reciprocal. Becomes a sine over the cosine. Instead of cosine over sine, we're going to multiply by sine over cosine. The sines cancel. You end up with, on the left side, 1 over cosine of theta. Wow. There it is right there. And that becomes the secant of theta. So we just cheated ourselves by saying the left side, 1 over cosine theta, looks exactly like the cosine theta. Good luck. If you have any questions, let me know. Email me, text me, call me, whatever. Thanks, guys. Bye.